do a really simple example next. I want to do the limit of a constant as x goes to a value of a. So for example, I'm going to bring up a graph here. This is the choice where my constant was 1. What is the limit of 1 as x goes to a? Well, it doesn't matter where I am on here. If I want to talk about this point right here, the limit as you get close to this point is 1. Limit as you get close to this point is 1. This point, every point you could get close to, the height of it's always 1. So no matter what it is, it's the value of 1, or in the generic case of an arbitrary c here, I'm going to say the limit is equal to c. Okay, here's sort of the next most complicated function. Not a constant this time, it's the variable x. So this is the graph of a straight line. It looks a little bit like this. And notice if I was to do the limit as we get close to 0.5 here, 0.5 is just equal to, well, 0.5. If I got close to the value of 1 up here, well, that's going to have this height of 1 over here. If I go up to 2, it's going to have this height of 2. So as we get close to any point A, because it's just this straight line, that the height of it is going to be A as well. And so the limit of the function x as the variable x goes to A is just going to be equal to A. Okay, what about all this nonsense? We've got a whole polynomial inside of here. What we get to do is we get to use these different rules, these limit laws, to very quickly figure this out. And I'm going to go slowly this first time, but in a moment, we're just going to answer this immediately. The idea is first, see, it was a sum of 3 different things, and we saw that the limit of a sum was the sum of the limits. So I can break that up as the sum of 3 different things. The sum of this first 3x cubed, the sum of the x, and the sum of the minus 1. It's 3 different limits. And we figured out what the limit of a constant was and the limit of x was. We know both of those. And I'm also going to try to break this one up. Notice we got a scalar, and then we got a product. X cubed is like x times x times x. So then when I advance this, what we're going to have is, first of all, the triple product, x times x times x, is 3 different limits here. The scalar gets built out of the front. That was one of our rules. And then for the limit of x and the limit of the minus 1, I just plug in those values we just saw, the a and the minus 1. And now I've taken the x cubed down to the limit of x. We've just seen what that was. You plug in a. And so what we're going to get is 3a cubed plus the a minus 1. In other words, what we've done here is we just took this a that was there and we just plugged it in. 3x cubed plus x minus 1 became 3a cubed plus a minus 1. So polynomials are really easy. There's nothing to do with the polynomial, you don't have to graph it. You just plug the value in. And indeed, it's true even slightly more general. It's true for something called rational functions. So this is a rational function f of x. It's a polynomial on the top and a polynomial on the bottom. And as long as you don't have the polynomial at this point a being equal to 0, because you'd have some sort of division by 0 thing, the limit is super easy. You just plug the value in. Whatever rational function you might have, its limit is you just take that a that you're taking the limit to and you plug it in. The same way this polynomial, we just plugged it in. So for a ton of these values, as long as you don't have a 0 on the bottom, as long as you don't have that problem spot, that for these rational functions, limits are really easy, you just plug them in.